Today is Chapter 11, Section 1, Square Root Property and Completing the Square. So completing the square, that's going to be, it's either going to be new to you or it's going to be something that you might have forgotten about. So that's good. So let's do this. We'll just start at the top. Alright, so solving quadratic equations by using the square root property. So let me get my other screen up. Alrighty. So we have already learned how to solve a quadratic equation by factoring and applying the zero product rule. So for example, if we took x squared is equal to 81, we know that we can subtract 81 from both sides. We know that we can factor that because it is a difference of squares. We can factor into x plus 9, x minus 9, and then set each one of those factors equal to 0, and we can end up with the solutions, x equal to 9, x equal to negative 9. Easy stuff. So it is important to note that the zero product rule can only be used if the equation is factorable. In this section, we will learn a method to solve quadratic equations containing expressions that are both factorable and non-factorable. Consider a quadratic equation with the form x squared is equal to k. The solutions are all numbers, real or imaginary, that when squared equal k. So for any non-zero constant k, there will be two solutions, right? It's going to be the positive component of k and the negative component of, the positive component of the square root of k and the negative component of the square root of k. For example, we have x squared is equal to 25. If we take the square root of both sides, we end up with 5i and negative 5i. This principle is stated formally as the square root property. Alrighty, so let's move this over here. Let's see. We'll write strategies for solving quadratic equations. There should be an S there. Let's try that again. Okay, so strategies for solving quadratic equations. Number one that we know of is factoring. Okay. Number two is what we're going to be doing today, and that's going to be the square root property. Square root property. Alrighty, and I put that in blue because that's going to be something new. We're also doing completing the square, and of course that would be the third strategy that we'll get to, and I'll write it as we get there. Alright, so let's see. Did anyone put this on the current page? Certainly. Right down there. Alrighty, so the square root property. For any real number k, if x squared is equal to k, then x equal to the positive component of the square root of k and the negative component of the square root of k, which we saw above. Oh yeah, the solution may also be written as plus or minus. You've seen that shorthand be used. Instead of writing, a positive and a negative, you can just put plus minus in front of it. Alright, so let's begin with an example. Alrighty, so to begin here, we're going to use the square root property to solve. So in order to solve for an equation, we must isolate it. So the first thing we're going to do is we are going to divide by 4. So we're going to have p squared is equal to 9 over 4. Good. Alrighty. Well, and so if we are squaring this variable, then we must, in order to get rid of the square, then we must square root. So we're going to take the square root of both sides. Okay, and when we take the square root of this right side, we have to put a plus or minus in front of it. Right? So continue on with the algebra. We're going to have a p, right? The square root of p squared is simply p. Is going to be equal to, it's going to be equal to the plus or minus of, and then we know the square root of 9/4. We know we can split that up into the square root of 9 over the square root of 4, okay? Which we know will be p is equal to plus or minus, what's the square root of 9? That is 3. And the square root of 4 is 2. And so our solution will be plus or minus 3/2. Right? So another example. Again, the first thing we're going to do is we need to isolate that variable. So it looks like we're going to have to subtract 75 from both sides. So we're going to have x squared, let's try that again. We're going to have x squared is equal to a negative 75. Okay. Sorry, 3x squared. Okay. And then we're going to have to divide both sides by 3. So we're going to have x squared is equal to a negative 25. Right? And then we're going to take the square root of both sides again. So we're going to take the square root of x squared and the square root of negative 25. And again, always remember this part. Let's actually make these equal signs a little bit smaller, so I can put that plus or minus there. Remember, always put that plus or minus in front. Right? And then, so the square root of x squared, well, that's just going to be x, and that's equal to. Alrighty, so we just learned about imaginary numbers. Even though you've known about them for a while, right? Because you learned them. Actually, many of you are still in high school, but you learned about them before. But we just got done with that section, so we know that we can take the I out, right? So it's going to be plus or minus. We can take the I out, and it'd be I on the square root of 25. So this would be I on the square root of 25, which we know to be 5i, right? So that's what we'll have, plus or minus 5i. Okay. And that takes care of example 2. And let's put this on here. This reads, a common mistake is to forget the plus or minus symbol when solving the equation x raised to k. So again, always put that plus or minus symbol there. Alrighty, so we use the square root property to solve the equation. So first thing we're going to do here is we're just going to go ahead and it looks like we're going to take the square root of both sides right off the bat. So we're going to have w plus 3 is equal to plus or minus the square root of 20. Okay, and of course we know the square root of 20 can be written as plus or minus. Take a 4, so it would be 2 on the square root of 5. Okay, we know that we can write the square root of 20 as that, right? Because 20 is 4 times 5, and we take the square root of 4 out, which would be 2. Right, and then of course we're going to subtract 3 from both sides, so we're going to have w is equal to negative 3 plus or minus 2 on the square root of 5. Okay, so this particular problem here, right, it's going to segue into the next part of this particular section, and that would be completing the square. So this is the w plus 3 quantity squared. So what we're essentially doing is we are squaring a binomial, right? Binomial is this polynomial where we have 2 terms, right? So we're essentially squaring that binomial. And then once we get to that point, it's very easy because again we took the square root of both sides. We ended up with this over here, and then w plus 3 on the left, and then of course we subtract 3 from both sides. But this form is what we're essentially looking for, right? Actually, this is what we're essentially looking for the next part of this particular section. Okay. And the next part is not going to be something that you enjoy. I'm sorry. solve quadratic equations by completing the square. So let's put this over here. Instead of writing everything, let's see if I can do this. Add library. I don't know if I've ever done this before, so let's see. And can we? Okay, well, this will be number 3, completing the square. That's a horrible H, isn't it? B. That's alright, so first of all, again, it's a lot harder to write on this than it appears. But anyways, this would be number 3, right? So if we did first being factoring, second being completing the square, the square root property, the third way to solve quadratic equations will be completing the square. Okay, so how do we do that? Alright, so this is basically showing what we did on the previous example, right? So in order to complete the square, one moment. So, let's see if this even describes it well. Yeah, okay, so notice how if we have x squared plus 10x plus 25, if I were to factor that, it would factor into a perfect square, x plus 5 quantity squared. Same thing for all 3 of these examples. Right? So how do we do this? Well, if we look at it, for a perfect, let's see, right here. For a perfect square trinomial with leading coefficient of 1, okay, so that tells us that we have to have a leading coefficient of 1. The constant is the square of 1/2 the linear term coefficient. All right, so that's a mouthful, right? But let's just break it down. Actually, let's not break it down. No, we will, but I have a better way, okay? So if this looks silly to you, I have a better way. Don't you worry. Okay, but it reads, the constant term is the square of 1/2 the linear term coefficient. Okay, so the linear term coefficient is obviously the one with simply the x to the first power on it. Okay, and the constant term is the square of 1/2 of it, right? So the square of 1/2. So what is half of -10? Well, that is -5, and then the square of that will be 25, and of course that's where we get 25 there. Okay. Instead, I do have a better way to go about doing this. I mean, this what the textbook has isn't bad. It's not bad. In general expression, this form is in a perfect square trinomial is n is equal to half b quantity squared. The process to create a perfect square trinomial is called completing the square. Let's see if we can. Okay, so what we're going to do, I'm going to do it my way. All right, here we go. So completing the square, it says determine the value of n. Okay, it's going to be what we complete the square with. That makes a polynomial a perfect square trinomial. Then factor the expression as the square of a binomial. Alrighty. So here's my way to do it. Now you don't have to do it this way, but I do suggest it. It's nice, fun, easy, and plus I'm gonna color coordinate it to make it super duper simple. Okay. So it's gonna be a 3-step process, right? But it's gonna look like 4. Okay, because I'm gonna have a 0th step. 0th, believe it or not, it is a word. Okay, and the 0th step is going to be this equation: b over 2 quantity squared. Okay, that's my 0th step. My first step I'm going to do is I will plug in my value of b. Okay, so notice how I left it blank because I'm going to be plugging that in. And again, b, we'll talk about that after this. And then step 2, I'm going to go ahead and do my division by 2. And then step 3 is going to be my squaring process. So it looks it's kind of blank there, but bear with me here. Okay, so we know a quadratic equation is written in the form ax squared plus bx plus c. right? We know that that's the form of a quadratic equation. We also know that a, b, and c, those are the values of my constants, right? A is the value of the constant in front of x squared, b is the value of the constant in front of the x, and c is my constant with no variable, okay? So the b over here is obviously going to be corresponding with this b here, the number that's in front of the x, or as the previous slide said, the linear term, right? So the linear term would be just the x to the first power. So the b value, that's all we're looking for right now, or looking at rather. So actually we'll keep that there. Let's make it white, maybe to correspond, to really make it stick out. B. Okay. So now let's start. Let's do A. Okay. So A. What is my B value here? Well, it is 12, positive 12, right? It is this value right here. Also, on the one thing that we definitely will follow from the previous slide is the coefficient being 1. Okay, the leading coefficient being a 1. And of course, we indeed do have the leading coefficient here being a 1. So we're going to plug 12 in for B over here. So 12 over here. Okay, and then just follow along with the color coordination here. All right, we're going to have 12, and then 12 divided by 2, well, that is 6, and 6. And then 6 squared, well, that is going to be 36. Okay, so here's how this works out. A would be x squared plus 12x, and then we're going to do plus 36 over here, like that. Okay, again, following the color coordination. I guess I could have written that in blue. Yeah, let's stay consistent with that in blue. I just like to be consistent. X squared plus 12x, that's going to be plus 36. Okay, well, that's the same thing if I were to write it in factored form, because again, this problem reads, then factor the expression. Okay, so if we were to factor that, then it will be x, okay, that should actually be green, plus 36. Then the factored form would be plus 6, and that's the quantity squared. Okay, so again, notice how this 36 at the tail end of the trinomial, right, the quadratic equation expanded out, corresponds with step 3. Okay, and notice how this 6 up here corresponds with step 2. Now here's the thing. You could, if you wanted to, and there's nothing wrong with it, but it does get a little tedious as soon as we get into like fractions and stuff, which we will see at least in both examples C and D. If you wanted to, you could look at this and be like, okay, x squared plus 12x plus 36. All right, so I know that factors into x plus 6 quantity squared. You could do that, okay, and there's nothing wrong with that. But again, the color coordination tells you right away that 6 is the factored form. All right, but let's move on, and then I will show you just how much easier it will become. Oops, not the eraser. All right, here we go. B. B is x squared minus 26x. Okay. All right, so negative 26, that's going to go up here in my first step. Negative 26. All right, negative 26 divided by 2. Well, that is negative 13. And the negative 13 squared is 169. That's 6. Sure. Okay, 169. There we go. Okay, so this tells me, now, again, just following the color coordination, right? 169 is going to be what I add to the end here, plus 169, and that's going to be equal to x minus 13 quantity squared. Okay, so real quickly though, but before I go too far, the process of doing this is so we can solve quadratic equations when we cannot factor. Okay, So let's see, we'll go back to something like this. Okay, if I were to, let's not do that. We'll do this. If I were to try and, well, that's not good either, is it? No, it is, okay. So if I were to try and factor this particular equation, okay, because again, as far as we know, the way that we solve quadratic equations, the first step that we always try would be factoring, okay? And if we're unable to factor it, we're going to use the square root method, okay? The square root method, which we saw for the first three examples, is again taking the square roots of both sides, okay? But if we, or not but if we can't, and in order to get to the square root method, we have to complete the square. Okay, so that's the whole point of actually doing this, is we are trying to solve quadratic equations. In case you were lost there. Okay. And of course, again, I'm probably jumping the gun. I probably should have just held that off until we actually got to that point instead of just talking about it for a minute, right? It's a waste of a minute. Good job, Sherman. That's okay. We always get out of here early, don't we? I think we can waste a minute. All right, here we go. So x squared plus 11x. All right, so this is an example of those fractions I was talking about. All right, so what is the value of my b? Well, that's 11. So put 11 here. Well, what is 11 divided by 2? That's very inconvenient. It is 11 over 2. Okay. Oh, I should put that in yellow. That is 11 over 2. Okay. And what is 11 over 2 squared? Well, 11 squared is 121. And 2 squared is 4. Okay, so this tells me I'm going to add 121 over 4. Now, here's the thing. Could you, and again, some of you probably couldn't, and I fully believe that, okay? Some of you probably could look at something like this and be like, okay, so the factored form of that, okay, well that's, it's going to be x plus 11/2, right? And of course, some of you could do that, but again, I don't know about you, but I don't feel like dealing with fractions and things like that. But, it is pretty simple if you do look at it. But that's also why I color coordinate this, because step 2 outlines it very perfectly what this actually is in factored form. It is x plus 11/2 quantity squared. Again, just following the colors. Also, this is a pretty interesting point, and it's actually funny because I was showing my wife something yesterday, and I'm pretty sure I did. It was 11, and my wife goes, is that 77, right? Just joking around with me. Although I guess my flags might have been a little bit longer, something like that. And she said, "Is that 77?" And she knows my handwriting. Now, obviously, it's not 77. But the reason why I put those flags on there is because this right here could be misconstrued as the absolute value of 2 over 4. All right, so that's why I put little flags on my ones to really distinguish them from something like that. Right? And of course, I have to do that because writing something small. See, I try to put a flag on that first one, but writing something small in this particular program, sometimes it just doesn't register. So that's why I had to do it there. In case you're wondering, again, I'm sure you guys are just sitting there wondering all these things, aren't you? Yeah, so that's our 4 steps that I kind of went over. All right, so now this is the whole reason why we need to learn completing the square. Okay, the whole reason why. So let's go ahead and put my steps over here. My 0th step is b halves quantity squared. My first step is I'm going to plug my b value in. My second step, I'm going to do my division by 2, and then my third step, is actually going to be doing the squaring part. Okay. So the reason why, if we were to look at this problem, x squared minus 6x plus 13. Okay, so x squared minus 6x plus 13. Can we factor it? We're looking at it. 13 is prime, 13 and 1. There's no way 13 and 1 can get me a negative 6. Okay, that's fine. All right. So that is the first way to do factoring. The second way is going to be completing the square root method. Well, I mean, we can't really do the square root method because there's nothing to square root yet. So we're going to have to incorporate the square root method. Okay, so this is the whole reason why we have to do the square root method in order to solve some quadratic equations, because we cannot factor it. So what we're going to do here is we're going to go ahead and move the 13 to the other side. This is equal to a negative 13. And now we're going to proceed with the square root method. Okay, so negative 6 is my value of b. 6. Negative 6 divided by 2, that is going to be negative 3. And then negative 3 squared, that is going to be 9. Okay, so what this tells me is the left side is going to be x squared minus 6x, and then we're going to add 9 to it, so plus 9. And then we know if we add something to one side, we have to add it to the other side, so we're going to say negative 13 plus 9, just like that. Okay, and then we're going to factor the left side because now it is a perfect square trinomial because of my completing the square. But we also know that from step 2, it's going to be x minus, let's fix that up, minus 3 quantity squared is equal to, well, what is a negative 13 and a positive 9? It's going to be negative 4. Okay, so now this particular problem is set up like example 3. Right, so I said, this is the form we're going to be getting into, and that, sure enough, that's what we have. Right, we have a binomial squared is equal to some number. We have that binomial here squared is equal to some number, and so then it becomes pretty easy, right? So what we're going to do is we're going to take the square root of both sides. So if we do that, it's going to be x minus 3 is equal to plus or minus the square root of negative goes a little crazy, huh? Negative 4, which we know is going to be x minus 3 is equal to plus or minus 2i. And then we add 3 to both sides. We're going to have x is equal to 3 plus or minus 2i. Okay, so it's that simple. Once we learned how to do it and figure it out, right? Example 5. Okay, this one is luckily going to be a fraction, right? I mean, we have to take care of fractions because nobody wants to get to that point in their homework when they're like, oh man, I don't know how to do this. I've never done something like this before. What do you have? It's quantity squared. Okay, now again, you don't have to write this out every single time, right? You can just have this set out to the side. But obviously, I put it every single time because I'm trying to teach it, right? Okay, here we go. So the constant is already on by itself, and I've got 2m squared plus 10m is equal to 3. Well, I said earlier that the first step where the value of the leading coefficient must be 1. Okay, well, we see here that the leading coefficient is 2. So what do? Well, we have to make it a 1. So how do we make it a 1? We need to divide this entire problem. We have to divide the entire problem by 2. Okay, so if I divide the entire problem by 2, I will have m squared plus 5m is equal to 3 over 2. Okay, so I divided the entire problem by 2. Now I can proceed. So what is my value of b? Well, that's a positive 5. Okay. And then 5 divided by 2, that is unfortunately 5 divided by 2. And then 5 divided by 2 squared is 25 over 4. Okay, so what we're going to do here is we're going to add 25 over 4 to both sides. So we're going to have m squared plus 5m plus 25 over 2. I'm sorry, 25 over 4. 25 over 4. That's going to be equal to 3 halves plus 25 over 4. Okay, now here's the thing. We could essentially, if you wanted to, kind of skip this step. Okay, we could skip this step because we know that the left side is going to be factored into m plus 5 halves quantity squared. Okay, and then the right side, well, the right side, let's go ahead and do the arithmetic here. Okay, so 3 halves, because okay, look in here, I need to get a common denominator. 3 halves with a denominator of 4 would be, would be 6 fourths, right? Does that make sense? So this is essentially going to be 6 fourths plus 25 fourths. Okay, so it's going to be 6 plus 25 is 31, so it's going to be 31 fourths. Okay, so we could essentially kind of skip this middle step. Well, we could skip writing this actually, and actually just write, this is equal to that. Okay, if you wanted to. Of course, this would just be a thing that you do the more you do it. That you practice along, right? But I guess for now, maybe not skip that step. Okay, and I won't either for the remainder of this particular section. So anyways, let's take the square root of both sides. So we're going to have m plus 5 halves is equal to the square root of 31 over 4, so it's going to be plus or minus the square root of 31 over 2, right? Because the square root of 4 is 2. And then lastly, what we're going to do is we are just going to subtract 5 halves from both sides. M is equal to a negative 5 halves plus or minus the square root of 31 divided by 2. All right, and that is my solution. So fractions, again, I mean, do they suck? Yes, I still hate fractions, right? But like I've said before in this, I'm pretty sure I said it in this section or in this class, fractions suck until you actually do it, and then you're like, well, it's not so bad. And of course, we see that here. And more arithmetic here. But all we're basically doing is adding on stuff that we know how to do, right? What I mean by that is we've seen problems like this, and we have to solve for x. We just have to really clear the parentheses, right? So let's go ahead and begin that. And actually, before I begin, let's go ahead and write this out. B halves quantity squared. Number 1, plug in my b value. Number 2, I'm going to do my dividing by 2. And number 3, I'm going to do my squared. Okay. So I'm just going to go ahead and distribute and clear that parentheses there. So we're going to have 4x squared minus 20x. That's going to be equal to negative 30 plus 6x. Okay. Alrighty. So what I'm going to do is I'm going to put on my terms of the variable on my left side and my constant on the right. And of course, all we have to do really is subtract 6 from both sides, right? 6x rather. So we're going to have 4x squared. And if we subtracted 6x from both sides, so we're going to have minus 26x. That's going to be equal to a negative 30. Alrighty. So lucky for us, this particular problem is not nice and neat. Okay. So what we're going to have to do is we're going to have to, before we even begin completing the square process, we're going to have a 1 in front of the x squared. Well, how do I get a 1 in front of the x squared? We'll have to divide the entire problem by 4. Okay, so what is 4 divided by 4 is 1, 26 divided by 4, and so on and so forth. So divide everything by 4, so I've got x squared minus 26 over 4x, and it's equal to a negative 30 over 4. And of course, the 26 and 4, that can reduce. It's going to be x squared. It's going to be minus 13 over 4x. I'm sorry, 13 over 2. That's going to be equal to a negative 15 over 2. Okay. So now we can begin to complete the square process. And of course, again, lucky for us, we have us a nice, pretty fraction to deal with. So let's begin. So what is my value of b? And again, the value of b is always going to be the one in front of the x value here. So it's going to be a negative 13 halves. So we're going to say negative 13. This is definitely not going to be it's close. Let me fix that one. Okay. Okay, so negative 13 halves. All right, well, negative 13 halves divided by 2, that is negative 13 over 4. And negative 13 over 4 is a positive 169 over 16. So this turns into x squared. Actually, I'm going to go ahead and do the thing where I said I'm going to skip a step, just to show you what I was talking about. Okay, so I'm going to go ahead and write this in factored form on the left side. The factored form on the left side, because I'm going to be adding 169 over 16 to the left, right? So it's going to end up looking like x minus 13 over 4 quantity squared, and it's going to be equal to negative 15 over 2 plus 169 over 16. Okay, so that's what I meant on the previous slide when I said we can kind of go ahead and skip this whole step essentially, but it's essentially going to be looking like this, right? Because I know that if I'm adding that term to the left side and the right side, well, if I add it to the left side, then the whole point of doing that is to get a perfect square like that looks like this, right? So hopefully this isn't going to be too confusing for this particular problem, but we're here. All right, so let's do this. So we're going to have x minus 13 over 4. That's going to be our squared. It's going to be equal to. Okay, so looks like my common denominator there is 16. Okay, so if my common denominator is 16, all right, well then this would turn into 120 over 16, right? So this would essentially be negative 120 over 16 plus 169 over 16. Right? Again, getting that common denominator. And of course, that ends up being 49 over 16. So that's what I'm going to put on the right side there. 49 over 16. Okay. And then now we can proceed. Well, we take the square root of both sides. We're going to have x minus 13 over 4. That's going to be equal to these plus or minus the square root of 49 over 16. Well, the square root of 49 is 7. And the square root of 16 is 4. Okay, so that's pretty easy. And then, of course, we add 13 fourths to both sides, 13 over 4 to both sides. So we're going to have x is equal to 13 over 4 plus minus 7 over 4. And, well, we can actually go ahead and do this, right? If we did 13 over 4, no, we'll keep it like that. No, let's not keep it like that. Okay, so 13 over 4, and let's do it because we can actually do this because it's really easy. We have the common denominator here, right? So 13 over 4 plus 7 over 4. Well, that is 20 over 4, which is going to be 5. Okay, so one of the solutions is going to be 5. So it's going to be equal to 5. And then the other solution is going to be 13 over 4 minus, I guess, there we go. It's going to be 13 over 4 minus 7 over 4. Well, 13 minus 7 is 6, so we're going to have 6 over 4, which would be 3 halves. Okay, and 3 halves would be my second solution. Okay, so hopefully that wasn't too terrible. And lastly, let's see. I guess That's essentially what we did, huh? When solutions are rational, combine like terms. That is, do not leave the solution with a plus or minus sign, right? Obviously, on the previous slides, we guess we didn't have to. I don't know. Since we have that square root of 31 there, we just left it as such. But since we can actually reduce this, we continued. Now for my favorite example of the day, because obviously I looked over this earlier, right? This reads, solving a literal equation. And I don't know, that's just really funny to me. It says just solving a literal equation. Hopefully you're chuckling on your end. If you're not, that's fine, whatever. We're 45 minutes deep. I don't blame you. All right, here we go. So ignoring air resistance. Okay, well that tells me right away this is a dumb problem because we can't just ignore air resistance, but whatever. So I wouldn't really call it a literal. The distance d in meters that an object falls in t seconds. So d is going to be meters, t is going to be seconds. So keep that in mind for whenever we proceed. And it's given by that equation. Solve the equation for t. Okay, so solving for t, that's not going to be too hard. Let's go ahead and, looks like we're going to divide both sides. So let's go ahead and, all right, for the sake of this, again, because I like to have the variable I'm solving for on the left, right? So let's go ahead and just turn the sucker around. Okay, again, all I did was just swap sides there. Okay, so first thing I need to do is I need to divide both sides by 4.9. So I will have t squared is equal to d divided by 4.9. And then we'll take the square root of both sides. So it's going to be t is equal to plus or minus the square root of d over 4.9. Okay, well, I'll solve for t. Here's the thing, though. I have a plus or minus. All right, and let's just deal with this for a moment. All right, since we're dealing with time, all right, I don't know about you guys, but we can't go back in time, can we? Right? So we're going to take the positive component of t here because it makes logical sense. And of course, we'll see that. I'm sure we'll come across Pythagorean theorem and do that later on, you know, and negative distances. But same principle. We don't have negative time, so we're not going to even. We're just going to ignore the negative component. So we're just going to look at the positive part, right? And I'm not going to put a plus there because it's implied if I don't put a sign in front. So there it is. I solved for t. All right, and then b. All right, using the equation from part A, which we got, right? Determine the amount of time required for an object to fall 500 meters. Okay, so again, the distance d is the one in meters. So all I have to do is put in 500 for d. So let's solve. So it's going to be t is equal to the square root of, and we'll put it in yellow, 500 divided by 4.9. Okay. So what is the square root of 500 divided by 4.9? So square root, and that looks like 10.1. So this is round to the nearest second, so I guess 10 seconds. So that's going to be equal to 10 seconds. Let's do, it just doesn't seem right. That's it. Yeah, 10 seconds. I mean, what's a whole second? But yeah, there we go. So that's how we do it. That's how we solve a literal equation. There you go. All right. So that concludes today's lecture.